Last episode, we won back the wasted GPU with paged attention and continuous batching. The same H100 now carries 3 to 5 times the traffic, but you do not implement those by hand. They live inside real serving engines, and those engines stack into one another like an onion. So the real question for a deployment is, how deep do you want to go? On-screen hook, 4 tools, 1 onion, pick your layer. Spoken callback, we just made the GPU efficient. Now we choose the software that actually ships those gains and add one last latency trick on top. Start at the core, the engine. This is the thing that turns weights into fast tokens with paging and batching built in. There are two you will meet. vLLM, open source, no compile step, run almost any model in minutes. It is where paged attention was invented. And TensorRT-LLM, NVIDIA's compiler that builds a custom engine tuned to your exact model GPU and precision for the absolute highest performance at the cost of a build step. Wrap the engine in a server, Triton. An engine runs one model. Triton runs your whole fleet, many models, multiple versions, all behind one endpoint, with metrics and health checks and the production plumbing. Each model is just a folder with a config file that says which backend to use, and Triton can host either engine inside it, vLLM or TensorRT-LLM. Wrap all of that in a microservice. NIM, one container you pull and Docker run. Inside it, NVIDIA has already put TensorRT-LLM and Triton together and tuned a profile for your exact GPU. It exposes the OpenAI API the whole industry already speaks, so your app talks to it with 3 lines of code, and it comes supported under NVIDIA AI Enterprise. The buy don't build layer. One more trick fits inside the engine, speculative decoding. Decode is slow because the big model crawls one token at a time. So let a small fast model sprint ahead and guess the next several tokens. Then the big model checks all of those guesses in a single parallel pass, keeping the ones it agrees with. You get several tokens for the price of about one big pass, and the output is mathematically identical to normal. The catch: it helps when the GPU is not already busy. Pile on a huge batch, and the extra checking work can actually slow you down. It is a latency tool, not a throughput tool. Let me draw the onion, then show the real artifact for each layer side by side. Then run the speculative decoding draft verify so you can see the tokens land. The onion from the inside out. Kernels at the core, flash attention and the fused attention math. Around them the engine, vLLM or TensorRT-LLM. Around that the server, Triton. Around that the microservice, NIM, speaking the OpenAI API, and the client on the outside. NIM is built on Triton and TensorRT-LLM. Triton can host vLLM or TensorRT-LLM. Layers, not rivals. Now the real commands, one per layer. vLLM serve with the model name and the flags from last episode. Paging and batching on by default. And an OpenAI compatible server comes up on port 8000. Hit it with the standard OpenAI client and you get your completion back. No compile step. TensorRT-LLM. The new high-level API is just from TensorRT-LLM import LLM. It builds or loads an optimized engine and you generate. Under the hood, the classic flow is start LLM build with FP8 and in-flight batching to produce an engine directory, which Triton then serves through its TensorRT-LLM backend. That's the config.ppbtxt with backend TensorRT-LLM. Compile once, serve at peak. NEM, one Docker run from the NVIDIA registry with your ngc key, and a production endpoint is live in minutes. Same OpenAI API auto-tuned for your GPU. The curl2/v1/chat completions returns just like any OpenAI call. This is the easy button, and it reports around 2.6 times the throughput of an off-the-shelf deployment, marked vendor reported. And speculative decoding live. The small draft model proposes 5 tokens, fast, in blue. The big target model verifies all 5 in one parallel pass in gold. A row of checks and one cross shows the longest correct prefix accepted, 4 or 5 this time, then it drafts again from there. The counter reads one big pass produced 4 tokens. NVIDIA reports around 3 times on Llama 3.3.70b for the right workload, vendor reported, and only in the low concurrency regime. So the decision is just how deep you go. Need it now supported enterprise, NIM, pinned model maximum performance, FP8, compiled with TensorRT-LLM, a mixed fleet of many models, Triton, iterating fast open source, any hardware, vLLM, same onion, you just pick your layer. That is the serving half of the cert. Next stage we go bigger than one machine. When the model itself won't fit on a single GPU, 3D parallelism, sharding, NCCL, and then the data center Kubernetes, and keeping it all alive at 3 in the morning. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.